Hey everybody, in this video I'm going to show you the proof for the law of cosines. Now there's no worksheet, no examples to follow, so there's no worksheet in the description below, but you can follow along if you want to. I'm just going to show you how we come up with this. And so with law of cosines, we start with a triangle that isn't a right triangle. So I'm going to call this angle A, I'm going to call this angle B, I'm going to call this angle C. So this is side A, this is side B, and this is side C. Now, we actually start this in a very similar way to the way we started law of sines, where we take this and bring it down, and there's the height. But notice that in the proof for law of sines, we only labeled these two angles. We didn't label that. We are here for this one. And one thing we're going to do is we're going to say this height breaks up this into two segments. And I'm going to call this x, whatever it is. So that leaves the rest of this, which is the quantity b minus x. And so what I have is I have two right triangles where I know all three sides. And since I know that they're right triangles, we can apply the law of not the law of cosines. We're proving that. We're going to apply the Pythagorean theorem. So over here, we have h squared plus b minus x squared equals c squared. Over here, we have x squared plus h squared equals a squared. Now, if you remember from the law of sines, what we noticed was that both trig ratios had h in it, so we solved for h. Well, both of these have h squared, so we're just going to solve for h squared. In some books, you'll see them actually solve for h. We don't need to do that. So over here on the left, h squared is going to equal c squared minus and the quantity b minus x squared. Over here, h squared is going to equal a squared minus x squared. Now, since they're both equal to h squared, now we can put them together. So we have c squared minus quantity b minus x squared equals a minus x squared. Now what we're going for is we're going for some kind of formula that uses a, b, and c. X we don't know. So therefore, we need to somehow get rid of x. So I'm going to expand this out. So we have b squared minus 2bx plus x squared equals a squared minus x squared. Now I distribute in the negative. So I have c squared minus b squared plus 2bx minus x squared equals a squared minus x squared. Now, what we have is we have a minus x squared on both sides. So if I add x squared, that will get rid of both of those. So we have c squared minus b squared plus 2bx equals a squared. So we got rid of the x squared, but we're left with this little x right here. How do we handle that? Well, we need to get rid of that somehow and leave it in terms of just a, b, and c. So if we go back to the top, where does x show up? Well, x shows up here. Now, x is the adjacent side of this right triangle. H is the opposite. But I don't want to use h because I don't know h, just like I don't know x. But we do know what a is. So off to the side, we can say, hey, wait a minute. We can use cosine. So cosine of c equals x over a. It brings in x, but we use a, side a, and angle c, which we can work with. But it keeps us away from h, which we don't know. So if I want to solve for x, I just multiply by a. So we have a cosine of c. That equals x. So now I can replace that over here. So we have c squared minus b squared plus 2b, and in place of x, we put our quantity a cosine of c equals a squared. Now, what I'm going to do is I'm going to rearrange a few things, because here is the law of cosines. It's just not in the form that you're used to. And so what I'm going to do is I'm going to move all of this over to the other side. And so what do we have? A squared plus b squared minus 2, and I'm going to rearrange the b and the a. AB cosine of c. And there it is. There is the law of cosines. Now, there are 3 different forms of this, and you can get that if you basically just rearrange the angles A, B, and C. And you know which one you're going to get because I ended up with the variant where you have c squared and cosine of c. And I knew that because x was adjacent to angle C. If x was adjacent to A, then it would be a squared on one side and cosine of A on the other end of the formula. Same for B. So if you want to try mixing up the letters to see what you get, go right ahead. But this is the approach that we use to get law of cosines. Again, it is only using right triangles, so that's why it's in the right triangle playlist. Thanks for watching. If you liked the video, click the thumbs up. For more videos like this, hit the subscribe button. If you have suggestions or problems you want to see worked out, type in the comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.